Hi, welcome to the 8th week of Consider This, Simplifying the COVID-19 Conversation. I and my co-host Heidi Beidinger have loved hosting you this semester and hope you can join us this Monday to talk about COVID-19 testing with Liz Ruley from the University of Notre Dame and Paul Hergenrother from the University of Illinois. So I posted some other tutorials about an overview of the different kinds of testing, one on antigen testing. I posted a previous tutorial on how PCR works. And in this particular tutorial, we're going to talk about serological testing or testing for antibodies. So if you remember our life cycle of COVID or SARS-CoV-2 infection, shown here, 14 days of recovery, that during this response, you have different immune responses. First, you have your first line of defense or your innate immune response, which happens early in infection. And it's really not until at least 7 days after infection that you start to get your adaptive immune response. Adaptive immunity are T cells and antibodies. And if you remember, we have different kinds of antibodies of different classes: IgM, IgG, IgA, and IgE. IgA is really important because it's in your mucosal surfaces. So you have IgA in your nasal passages. But for serological testing, we usually are testing the blood. And so that means you're looking for IgM or IgG, and actually most of them measure IgG. Now, these different antibody classes come up at different times during an immune response. And so the first ones to come up are IgM. And really, you don't get a lot of IgG till well into the infection, even in the recovery period. And so that's really why when you get an antibody test, you're not testing to see if you're infected. You're testing to see if you've ever been infected. And so in the next slide, I'll tell you a little bit how it works. And so really what we're trying to identify are any antibodies, IgG in particular, that are recognizing the virus. And this is usually done with an assay or a test called ELISA, which stands for Enzyme-Linked Immunosorbent Assay. There are other ways to do it, but the concepts are generally the same. So in this case, it requires a blood draw. And you put the blood in a tube, and actually the red blood cells in the blood are lysed. And so really you just have the fluid part of your blood or your serum. And that contains, among other things, antibodies. Then you also have a plastic dish, and usually these are done in dishes that have lots of wells, and so you can do multiple tests at a time. And you coat that plastic dish with virus protein. And in this example, we have the spike protein because that's really the antibodies that you want to look for, are those antibodies that respond or recognize the spike protein so it can block infection. So then you take your serum sample and you put it into the well, and so you have your serum, which contains the antibodies. And those antibodies that recognize the virus protein or the spike protein will bind, and then you wash everything else out. So the only ones left are the ones specific for the virus. Then you add in a secondary antibody. So this is an antibody that you know, and in this example, recognizes IgG. So you can tell if these antibodies are IgG. These secondary antibodies are coupled to an enzyme. And that enzyme will react to a substrate and cause a color change. And so then you can measure that color change. And so if you have a lot of those virus-specific antibodies and then the secondary antibodies, you can get even a stronger color change. And so you can measure relative levels. So if you remember, the job of antibodies are to neutralize the virus, to really bind the virus and block it from interacting with its host cell receptor to gain entry into the cell. And this is called neutralization. Now, just measuring antibodies does not mean all of those are neutralizing. Because some antibodies can recognize the virus, but in fact not neutralize. So you don't know for sure that all those antibodies that you're measuring in that antibody test are effective at blocking the infection. It really is only telling you that you've been exposed to the virus at some point. Anyway, I'm looking forward to talking to you on Monday, and I hope you can join us. Bye.